kindergarten and TK students. Welcome to my kitchen. So today we are going to talk about forces. So in kindergarten, you guys saw me right before school was closed. In TK, I was going to have you in the next Monday to start forces. So I just want to go over what a force is. So a force is a push or a pull. So do that with me. A force is a push or a pull. Okay? And so for the kindergartners, if you remember, we did the tracks and the cars, and we had a lot of fun running the cars down the tracks. And we learned about two forces. We learned about the force of gravity, and gravity is the pulling down force. And gravity is why when you let go of something, say this pen, and you let go, it drops because gravity is pulling the pen down. So the other force that we talked about was the force of friction. And if you remember, friction is the stopping force. And in our car experiment that we did, we saw that the carpet helped stop the cars from rolling. And so the carpet provided friction for our cars. So today we are going to learn about the force of air pressure. So air pressure is the weight of air pressing down on our earth. And so we don't feel air pressure because as much as the air is pressing down on our bodies are pressing back. So we don't feel it if we're standing still. However, if you go outside and the wind is blowing, then you feel air pressure. Air pressure is important for planes flying. It's important for changes in weather. And I wanted to go over what pressure is. So pressure is just when you push on something. So you can gently put your hands together and press on them. So that is pressure. Okay. So in weather, if you have higher pressure, so if this one's going to push harder than this one, the higher pressure is going to push the low pressure out. And also, the lower pressure will also help pull the higher pressure as it pushes. So that's how it's a force. It's a push or a pull. Okay, so now I'm going to do a demonstration of air pressure. Now this is an experiment that I'm going to do. For safety reasons, you're not going to do this experiment. So what I actually already did is I heated up some water because I wanted to get a jump on the experiment. I added, just about an inch of hot water to my can, and I'm going to heat up water in a pan, and that will in turn heat the water inside of the can, which will then create steam, and the steam is going to push the air out of the can. So what this does is that since the air is being pushed out of the can, that the air pressure inside of the can is going to be less than the air pressure outside of the can. So what do you think will happen? Okay, so let's try the experiment. All right, so I had everything boiling and hot, so I don't know how long it will take, but we have to watch the can, and one of the key parts of this experiment is you have to make sure that there is steam coming out of the top of the can. All right, so I've heated up the water inside of the can. I checked to make sure that there was steam coming out of the can, and I put it back. So that is where we are. So what I'm going to do now is turn off the flame, and then I'm going to take the can and turn it upside down into some cold water, and we're going to see what happens. All right, I'm going to take the can and put it into the water, and we'll see what happens. 1, 2, 3. All right, so here is our crushed can, and I am curious if you predicted that the can would crush. Now remember, what I said was that after we heated up the water inside of the can and the steam pushed the air out, that there was lower pressure inside of the can, higher pressure outside of the can. So more pressure outside will push the lower pressure inside and crush the can. All right, so now it's your turn to do experiments. And the first experiment you guys are going to do is you are going to use whether you have the plastic funnel and the ping pong ball, or if you made your own funnel out of paper and your own ball out of paper. Okay, so what I want you to do with this experiment, and I want you to be thinking about the force of air pressure as you're doing the experiment. I want you to try two different things. One, I want you to turn the funnel upside down and put your ball inside the funnel, and using air pressure that you create by blowing, I want you to try to blow air into the funnel and see what happens to the ball. What do you think will happen? Will it stay the same? Will it come down? Can you blow hard enough and push the ball up, either up farther in the funnel or outside? Okay, so that's the first thing I want you to try. The second thing I want you to try is to put the ball on the table and put your funnel over, and then do the opposite. Instead of trying to blow to push the ball up, I want you to try to suck in air to try to pull the ball into the funnel. So go ahead and do this. I will do it too, and we'll see what happens. What do you think? Okay. So what happened in your experiment? So I tried it both ways as well. And I don't know about you, but I could not move the ball in the funnel, whether I tried blowing it this way or whether I tried to suck it up this way. And the reason is that because of the shape of your funnel, that you have more area for air at the top of the funnel than the bottom. So when you're trying to blow through this smaller space, you cannot blow hard enough to overcome the force of the air pressing down. That's why your ball won't move. And the same goes for this, is that you cannot suck up the air with enough force to make the ball move up into your funnel because there's more pressure here. So your ball can't move because of air pressure. All right, so the second experiment I want you to do is the one with the bottle and the paper ball. So I did this, and the overall experiment is you are going to put the ball of paper on the lip of the jar, okay? And you just want to make sure that you don't put the ball into the jar. You want to put it, you want to put it so that the ball is kind of a little bit inside the jar. Now what I want you to try to do is, from the force of air pressure, once again, from your body, your lungs, I want you to try to blow with all your might. Try to blow the paper ball into the container. What do you think will happen? What's your prediction? All right, so you go ahead and try the experiment, and we'll see the results. Okay, did you try it? What happened? Could you blow the ball of paper into the container? Okay, I couldn't. Okay, did yours look like this? Not only did I not blow it in, it came back out. So what was going on? So the jug doesn't look like it has anything in it, but it's actually filled with air. So as you are trying to blow a piece of paper, which also takes up space, and using air, right, from your lungs, it's already full. So what you're actually doing is you are blowing in, and to create space for that air, it's pushing the ball out. And that's an example of air pressure. All right, so I hope you had fun with that one. Now we're going to do our third experiment. And this is the experiment where I want you to have a glass of water. Now you can see my glass is pretty full, okay? And I think that index cards work the best. Cardstock probably is very similar to the index paper. Construction paper might work. I haven't tried that one yet. And I need a bowl to, here it is. All right, so I'm going to use a bowl for this experiment. Now what I want you to do is get a cup of water, pretty full, and you want to have it so that the water is pretty much to the top, and actually when you put it in, you can go ahead and have the water spilling over the edge. Then I want you to place, and you might, depending on the size of your hand, you might need to get help for this one. Place the paper on top of the water, put your hand, and then over a bowl, you're going to flip it over. And we're going to see what happens. What do you think? Do you think the gravity will pull the water down and make the paper fall down? Or do you think that the paper will stay on the cup? What is your prediction? Okay, so go ahead and do the experiment. All right, so now I am going to try this. I'm going to hold it over a bowl because I don't want to make a mess. And that way I can use the water also to water my plants outside. So I'm going to put my hand over the paper, and the thing is you need to get a good seal, okay, around the piece of paper over the rim of the glass. And I'm going to, paper stayed on. So is this what happened to you? You can see I did spill some, it's coming off the paper. What do you think will happen once the paper absorbs or soaks up all of the water? Do you think that this paper will stay on? So I can sit here, or you can sit here and wait for the water to get completely soaked up and see what happens. But why did this paper stay onto the cup? Because there's so much water in there, you would expect the force of gravity to pull the water and force the paper to fall down. Well, it's because of air pressure. So the air pressure is greater than the force of gravity trying to pull the water out. And so air pressure is actually pushing the paper on the cup. Now, if I let it sit here for a long enough time so that the paper would absorb a lot of water and the paper would start to kind of break down, then what would happen is the gravity would win, because there would be holes in our paper. All right, so I would love to hear from you. I miss hearing from you guys, and so I have this email address right here, which is drjensencv@gmail.com. So I would love to hear any kind of predictions you made. Were your predictions right? Were they wrong? And remember, predictions are guesses, right? So it's okay if your prediction was wrong. And I would like to hear, did you come up and do any other experiments with air pressure? What things can you come up with? All right, have fun.